Now here's a statistics problem. I rolled 10 dice. What's the probability that I obtain exactly 2 sixes? Lots of ways of answering this question. A very long way would be to draw a tree diagram. The first event, I either get a 6 or I don't get a 6. Second event, 6, not a 6. 6, not a 6. Third event, 6, not a 6. 6, not a 6. 6, not a 6. 6, not a 6. And so on. So far on this diagram I've gone 1, 2, 3. I need to draw another 7 sections, and obviously the number of branches is doubling each time. This is going to take a long time, possibly a couple of hours. So let's think if we can find a shortcut for that. This situation is an example where the binomial distribution is going to help us. The word binomial starts with the letters B and I. The words bicycle, biplane, biped also start BI, and they're all involved with the number 2. So in this situation there are 2 possible outcomes, which are often called success and failure. Either we're going to get a 6 or we're not going to get a 6. So for a binomial distribution to be appropriate, we need 2 possible outcomes. We also need a fixed number of trials. A trial is 1 event. So in this case we had 10 throws of the dice, so the fixed number is 10. We also need a fixed probability. An unchanging probability has got to be the same every time. So the fixed probability, the probability of getting a 6 is 1/6, and that is unchanging. And we also need the trials to be independent of each other. If we get a 6 the first time, that doesn't change the probability of getting a 6 the second time or the third time. So the probability is always going to be the same, and the outcome of one event does not influence the outcome of the next event. So in this situation we can say that x, which is going to be the number of 6s, has a binomial distribution where the number of trials, or the number of events, is 10, and the probability of success in each case is 1/6. So this notation is used to show we've got a binomial distribution, and we need to define what x is. It's the number of 6s. What we're looking for is the probability that x equals 2. So let's think about this. Supposing the first 2 trials give us a 6, and the next 8 don't give us a 6, not a 6. The probability of getting a 6 is 1/6, and the probability of not getting a 6 is 5/6. So the probability that this is what we get is 1/6 squared times 5/6 to the power 8. 2 is the number of 6s we get, so that power there is 2, because we're looking for the probability of getting 2 6s. We want 2 6s and 8 non-6s. But this is not the only possible way of getting this. It could be 6, not a 6, 6, and then followed by 7 6s. But this probability is also the same, because we're going to get 1/6 squared, that's these 2, that 6 times that 6, and then we've also got 8 non-6s. There's lots of possible ways of this happening. How many ways are there of this happening? And in order to find out that number, we need to think about the work we've done so far on the binomial expansion. So let's think about work we've done previously on the binomial expansion, and let's consider 5/6 plus 1/6 to the power 10. We know from that work that this works out to be 5/6 to the power 10 plus 10 times 5/6 to the power 9 times 1/6 to the power 1 plus 45 times 5/6 to the power 8 times 1/6 to the power 2 plus 120 times 5/6 to the power 7 times 1/6 to the power 3, and so on. Now these numbers in front of the fractions, the 1 that's implied there, the 10 that's there, the 45 there, 120 and so on, these are the binomial coefficients. And we can work out the binomial coefficient either by using Pascal's triangle or by using the formula that NCR, where C stands for combinations, because we're looking at the number of combinations here, is n factorial over n minus r factorial r factorial. Now this binomial coefficient can be considered as the number of ways through a tree diagram, because what we're looking at in this question is how many ways are there through the tree diagram, where we get 8 non-6s and 2 6s. So this is the number of ways of getting 5/6 to the power 8 times 1/6 to the power 2 in this expansion. And so what this means is that this section here of the expansion is the solution to our question. We're looking for 8 events which are not 6s and 2 events which are 6s, and this can occur in lots of different ways, and the number of ways of getting this is 45. So the answer to our question is the probability that x equals 2 is 45 times 5/6 to the power 8 times 1/6 to the power 2, and that works out to be 0.291 to 3 sig figs. So let's consider this example where a dice is rolled 50 times. What's the probability of obtaining 10 2s? So if x is the number of 2s, what's the probability that x equals 10? Well, x is in a binomial distribution. There's 50 events, and the probability of getting a 2 each time is 1/6. So the probability that x equals 10 is 50c10, 1/6 to the power 10, 5/6 to the power 40. Just check you're happy with that, wherever these numbers come from. Well, there's 50 events, and we're looking at the probability of getting 10 2s. The 10 is by the event of getting the 2s, so it's 1/6 to get a 2, it's 5/6 to not get a 2, and there's 40 of those events. So there's 10 2s and 40 non-2s. So we just need to work this out, and that works out to be 0.116 to 3 sig figs. Just check you get that answer yourself.